Hi everyone, this is your math guru. In this video, I'm going to show you how to solve the following trigonometric equations. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. In the first example, we have find the general solution of 1 plus sine theta equals cos squared theta. In this equation, we have more than one trig function, which is your sine and your cosine, and dividing by cos theta in order to change that to a single trig function of 10 will be a bit difficult because of the one we have hanging here. So the next option is I'm going to try using my trigonometric identities. This states that my sine squared of x plus my cos squared of x equals to 1, and making cos squared the subject of formula, that will be equal to 1 minus sine squared x. So therefore, I'm going to replace my cos squared x. I have that as 1 plus sine theta equals 1 minus sine squared theta. The next step, I move all the terms to one side. So I have 1 plus sine theta minus 1 plus sine squared theta equals to 0. You can see that I have my 1 minus 1, that's 0. And if I rearrange my expression on the left, I have that as sine squared theta plus sine theta equals to 0. To solve for sine theta, I'm going to start by factorizing. Taking out the common factor, which is sine theta, I'm left with sine theta plus 1 equals to 0. So we have sine theta equals to 0, or sine theta plus 1 equals to 0. So what we're going to do now is to solve each equation separately, and then we combine our answers at the end. So I go back to my cast diagram, and starting with sine theta equals to 0, I'm going to treat as 0 as a positive value. And if I go back to my cast diagram, my sine is positive in the first quadrant and in the second quadrant. So starting with quadrant 1, I have my reference angle. I'm going to start with sine theta equals to 0. So therefore my reference angle is equal to arc sine of 0, and arc sine of 0 will give me 0 degrees. So therefore my theta in the first quadrant will be equal to reference angle plus k 360 degrees. 360 degrees is a period for a sine graph. That's equal to my 0 degree plus k 360 degree. Therefore, my theta equals k 360 degrees, where my k is an element of integers. So I'm going to do the same for my second quadrant. So I have quadrant 1, quadrant 2. In my quadrant 2, I have that as the same sine theta equals to 0. Already I have my reference angle equals to 0 degree, as shown in my quadrant 1 calculation. So therefore, my theta will be 180 degree, that's the reduction for my second quadrant, minus the reference angle plus k 360 degrees. That's equal to 180 minus 0 degrees plus k 360. Therefore, my theta equals 180 degrees plus k 360 degrees, where my k is an element of integers. So therefore, I've been able to solve for sine theta equals to 0, and I got that for my first quadrant and the second quadrant. Now I'm going to solve for sine theta plus 1 equals to 0. I'm going to go through the steps again. So for my sine theta plus 1 equals to 0, I have my sine theta equals negative 1. If I go back to my cast diagram, sine is negative in the third and in the fourth quadrant, such that I need to work separately for each of those quadrants. I start with getting my reference angle. To get my reference angle, I have reference angle equals the arc sine of 1. I ignore the negative value, and that is going to give me 90 degrees. So therefore, going to quadrant 3, in my quadrant 3, what I have is 180 degrees plus theta. So I have my theta will be equal to 180 degrees plus the reference angle plus K 360. We're still working with a sine that's equal to 180 degrees plus 90 degrees plus K 360 degrees. And that will give us, therefore, theta equals 270 degrees plus K 360, where my K is an element of integers. Then I need to work for my fourth quadrant. I'm going to have the same value, I think, but I'm going to work that out. In quadrant 4, I have my theta equals 360 degrees minus the reference angle plus K 360 degrees. That's equal to 360 degrees minus 90 degrees plus K 360. Therefore, theta equals 270 degrees. So I'm going to get the same value, 60 degrees, where my K is an element of integers. So therefore, I'm going to combine all my answers together that I got for theta, and that will be the general solution for 1 plus sine theta equals cos squared theta will be theta equals K 360 degrees, or theta equals 180 degrees plus K 360 degrees, or theta equals 270 degrees plus K 360 degrees, where my K is an element of integers. Now let's go to the second part of the question that says solve for theta if 2 cos squared theta plus cos theta equals to 3. In this example, I'm going to start by writing in standard form, maybe moving all the terms to one side, and then solve like a trinomial or factorize in the trinomial. So I have 2 cos squared theta plus cos theta minus 3 equals to 0. And if I solve that, I have 2 bracket equal to 0, factorizing, that will be 2 cos theta plus 3 close bracket. Then I have cos theta minus 1. So therefore, my two values, I have 2 cos theta plus 3 equals 0, or cos theta minus 1 equals 0. So what I'm going to do, like I did in the first example, is I'm going to solve the equations separately, and then I combine my answers at the end. So starting with the first one, I have 2 cos theta plus 3 equals 0. Therefore, in this case, my cos theta will be equal to negative 3 over 2. Going back to my cast diagram, we can see that cos theta is negative in the second quadrant and in the third quadrant. So therefore, the first step is to find my reference angle. So I have reference angle equals to my arc cos of 3 over 2. I ignore the negative value, and that will give us a no solution. So what that means is cos theta has a minimum value of negative 1. So therefore, cos theta cannot be equal to negative 3 over 2. So therefore, I only need to work with cos theta minus 1 equals 0. So therefore, working with my cos theta, minus 1 equals to 0. Make cos theta subject to formula. That will be positive 1. If I go back to my cast diagram, cos is positive in the first quadrant and in the fourth quadrant. So I start with quadrant 1. In my first quadrant, I need to get my reference angle because I have cos theta equals to 1. My reference angle in this case will be the arc cos of 1, and that is equal to 0 degrees. So therefore, in quadrant 1, I have my theta equals my reference angle plus k 360 degrees, and that is equal to 0 degree plus k 360 degrees, which is equal to k 360 degree, where my k is an element of integers. So I'm going to do the same for the fourth quadrant. I have quadrant 4, whereby my theta, and the reduction for that is 360 degrees minus my reference angle plus k 360 degrees, that is 360 degrees minus the reference angle, that's 0, plus k 360 degree. Therefore, my theta equals 360 degrees plus k 360 degrees, where my k is an element of integers. So therefore, you can see that I have the same solution for the two quadrants, which is k 360 degrees and k 360 degree, because the 360 degree does not have an effect because that's a complete revolution round. So therefore, the final answer, the value of theta, will be k 360 degree, where my k is an element of real integers. Thanks for watching. Bye.